I'm John Garland, Vice President of Cloud Development at Wintellect, an Azure MVP, a certified trainer and instructor at Wintellect. And you can find out more about me at wintellect.com and the .NET Gator Twitter handle there. Today we're going to be talking about the one of the many ways that best practices guidance at Azure has evolved over the years. The latest, the newest, the current right way today for doing things. We're going to look at using managed identities in Azure to help your applications access other Azure resources. This talk, as I mentioned, is brought to you by Wintellect. Wintellect is a world leader in software development, Azure Cloud Platform and Services, and developer training. We're a Microsoft Gold partner in cloud, DevOps, data, app development, and learning, and we won the 2018 Worldwide IAMCP Partner Award and the 2019 MSUS Partner Award for Intelligent Cloud DevOps. And in addition to all that, we here at Wintellect have been leading industry influencers from Microsoft and cloud technologies for many years. Our team members have written dozens of books, and our content is used in magazines, trade shows, blog posts, and academic content, to name just a few places where you might run into us. And as a special announcement, for attendees of this webinar today, are eligible for a discount on Wintellect private on-site training. If you're interested, please contact us at training@wintellect.com and mention this talk to take advantage of the offer. Okay, so let's talk about why we're here today. As Azure enters its adolescence, a lot has changed. When we first started, we had a limited number of services available to us. It's about 100 or so now. We basically just had compute and storage. To access storage from your compute services, you needed to include an access key in your requests. And we had a lot of sternly worded warnings about the need to protect these keys, since they basically gave anyone who had access to them carte blanche access to do whatever they wanted with the data in your storage accounts. We were given 2 keys to each account so we could implement rotation strategies to help minimize the chance of rogue keys being used, and so on. Over time, the best practices evolved there to using shared access signatures and what's known as a valet pattern. The valet pattern kind of being like, some of your cars may have a specialized key that's meant to give out to valets when you check your car at a valet stand. The key will let the valet enter and exit the car and pretty much just drive it to and from the parking spot, but won't allow them to use some of the fancier features in your vehicle if you happen to have those. The same idea here. You could generate a special key that applications or other people could use to access the information in storage, but it was restricted in terms of the scope of what it could do, and in some cases in terms of where the request could originate from. Also, these keys tended to have a limited lifespan as well, after which time they weren't useful and needed to be refreshed or replaced. So this kept our keys, our access keys, a little bit more secure. And again, it meant that we could limit the access that services had to our storage rather than this full carte blanche access. A little later on, additional services started showing up in Azure, and they had different combinations of API access keys, share signatures, and so forth to protect the data that they worked with. Now, what's the big concern with using keys? The problem is they generally need to be stored somewhere for our applications to use them. Sometimes in code, that's generally a bad thing because that ends up in source control repositories and ends up getting spread out outside of where the application is running, and it's hard to track. You don't know where your keys are ending up. Sometimes they're in code-related settings like configuration files. They can be in settings stores provided by our cloud services. And if they're lifted from there, we can run into problems because their use is, as I mentioned, carte blanche, pretty unrestricted in terms of what they can do. And as we've seen, this has resulted in things like ransomware attacks, where someone does you the nice favor of encrypting all of your data and offering to sell you back the key to unencrypt your data that you no longer have access to. And when those things happen, patient records are lost. We've seen the Wood Ranch Medical, they lost their patient records, and basically the practice couldn't continue after that. It was a catastrophic failure for that enterprise. We're seeing millions and billions of dollars of issues because of improperly secured or other just available to attack vectors data that's stored up in the cloud. So that's where, again, good security practices help, key rotations, shared access signatures, things like source IP restrictions. But ultimately, the question does come down to who has access to the places where these keys are stored. So let me kind of illustrate this with a bit of an application here. I've got a very basic web application here, a demo application. It's just your typical run-of-the-mill ASP.NET Core application. It happens to leverage Azure storage, and it leverages a database. It's got keys that are stored in a settings file. For the most part, my regular settings file is okay. It only accesses developer storage, and I'm using a user secrets approach to hide the real keys from here in the application. But you'll see, I've got the application. It's a fictitious motorcycle parts store. And I can log in, and the login is backed by the database. The parts are stored in a combination of Blob storage and Azure table storage. If I come on over to the Azure portal, and of course I have an error there. If I come on up to the Azure portal and I look at the configuration file for the service though, you'll see I've got all these values in my connection strings. And if I bring them up, you'll notice my connection strings include things like my account key, storage key for my storage, and they include username and password information for my database. So if I've given a junior developer access to my storage account, congratulations, I've just given him a job promotion. He's now potentially a DBA too, just because by the virtue that he can come on in here, and what I thought was innocent enough, I gave him access to the cloud, to the website in Azure. Well, no, now he also has access to the sensitive information that happens to be included in that website. Okay, let's see, in configuration. By the way, this developer also happened to be a little industrious and decided he's going to incorporate some service health information inside of the database. So give us a nice little service health endpoint, and I can go ahead and bring it up. And hey, congratulations, my industrious developer has made it convenient for me to see what my connection strings are right here on my site in production, including my various database passwords and my storage access keys. That's not good. You see, it can be, somewhat innocent actions can take this sensitive information and put it in places where we don't want it and expose us in our company to risks that we don't want to be exposed to. So what can we do about this? Well, there is an alternative available to leverage access between services, a relatively young one when it comes to all things Azure. It was introduced a few years ago with role-based access control. This allows us to restrict access to certain resources to certain users, groups, or applications. You can do this by assigning an access role to an identity for a particular resource. There are a bunch of predefined built-in roles that govern general behavior or resource-specific behavior, but most of them are built around this pattern of owner, contributor, or reader roles in some way, where owners can manage everything about the resource, including access to it. A contributor can manage everything except they don't manage being able to control access for other people to it. And readers can just see things, but they can't make changes. And by the way, you can also define custom roles beyond the pre-built roles. Now, in order to use role-based access control in Azure, the thing that needs access must be represented by what's known as a security principal in Azure Active Directory. And there are two kinds of security principles we can work with. User principles represent users or groups, and service principles represent applications. And then on these principles, we can assign access policies and permissions to go ahead and access and work with resources in Azure. So what this lets us do is in our code, we can now do something that looks a little bit like this. This is actually using the Azure Management Fluent SDK as an example. But you can see here, we can take a a service principal given a ID and a key, or sometimes called a client secret for the service principal, I can create an instance of the Azure Credentials Factory, which is provided by this management SDK. And from that, I can create a set of credentials based on that service principal using that client ID, the Azure Active Directory tenant they're a part of, and which particular Azure cloud environment I happen to be working with. Then I can call Azure and authenticate with those credentials for the subscription that I want to work with. And this will give me a handle that I can use to access the resources in Azure to which this service principal has been granted permissions to work with. However, in a program that does this, where do you suppose that client ID and client key set of values comes from? Are they in the configuration storage? Did we just exchange one set of credentials that are stored in storage, or that are stored for another? So we get kind of a little bit of a chicken and egg scenario, and maybe there's a way that we can do a little bit better. So the question is, what if Azure could help us out here? What if Azure could basically slap a name badge on all of its services, and the things that we want to restrict access to could look for that name badge that Azure has issued? So the process would look something like this. We go through a couple of configuration steps where we create an identity for an application or a service, and Azure Active Directory would create a managed service principal, a service principal that it manages and is in charge of. And then we could use role-based access control for a resource and configure it to grant a set of permissions for that identity that we just created. And Azure Active Directory would record the role-based access control information. And then during operations, when we're actually running our code, an app would need access to a particular resource that's been secured with this role-based access control. The app would actually get its identity from Azure and request a token from Azure Active Directory for that identity. Azure Active Directory returns a token. The app would include that token in a request to the resource. The resource checks that token out, makes sure that it's a legitimate token and that it meets the required role-based access control permissions, and it would then return the results. That is the basis behind Azure Managed Identities. So the idea here is, tipped over my tongue here. So the idea here is that Azure Managed Identities allow Azure itself to assign a special service principal identity to an application, and that special identity can then be used to establish permissions and access rights to the applications, for the application regarding the secured item that it's trying to access, such as a Key Vault resource, an Azure SQL resource, an Azure Storage resource, or what have you. You can assign that there are two kinds of of managed identities that Azure can assign. One is either a system assigned identity, where Azure creates the service principal in Azure Active Directory and manages its lifetime along with the application. And there's also the idea of a user assigned service principal or user assigned managed identity, where you create the managed identity as a resource in a resource group in Azure, and then you can assign that to one or more services, and they will go ahead and use that particular identity value instead of one that they manage. The upside with the user assigned also is that if you remove the application, the identity continues to exist beyond the lifetime of the application. Again, so you can share it between applications, or if you're doing anything that involves a major overhaul of the application and involves tearing it down and resetting it, the identity would persist and you wouldn't have to reset the role-based access permissions for that particular identity. Like I said, like any service principal, these identities can be used to configure role-based access control. And there are two sides to this coin. There are services that support having managed identities given to them, and there are services that support Azure Active Directory role-based authentication. Basically, the services that support having a managed identity assigned to them are the ones that you would consider typically the applications, the ones that are going to be running code for you. Things like Azure Virtual Machines and Virtual Machine Scale Sets, which support both service and user assigned managed identities. Azure App Services, the web applications and functions, same thing. Azure Blueprints, Logic Apps. Azure Data Factory v2 only currently supports service-issued managed identities. API management supports service-issued managed identities, and user-issued are in preview. Azure Container Instances, and so on and so forth. But again, these are the things that are executing your code which would need an identity to request to access another service. And then you have the services that support Azure Active Directory role-based access control. Things like Azure Resource Manager itself, Azure Key Vault, Azure Storage for blobs and queues only, not tables. I believe files is in there now as well to an extent. Azure Service Bus, Azure SQL databases, and again, so on and so forth. These lists continue to grow and continue to evolve. So working with this is a bit of a 1, 2, 3 process. First, you create a managed identity on a service. Then you give the identity permission to access a given resource in another service. And then you update the code that's going to be calling to retrieve the resource, and you set that up to actually retrieve and exchange a token. So for example, if I have a web application that's accessing Azure Blob storage, I can go into that web application and give it a system assigned managed identity by enabling it inside of the portal or through ARM templates or what have you. But I enable that system assigned managed identity. You'll see that identity has an ID, a service principal ID of 73F85, etc. And then I can go into storage, and in the identity and access management configuration for my storage account, I can add a new role assignment. In this case, I'm going to say that this storage account is going to grant a role of storage blob data contributor, back to that contributor, owner, and reader hierarchy that we mentioned earlier. And I'm going to give access to this IntelliPix application to have that particular role within this storage account. Then inside of my code in my web application, I would go ahead and add some code for accessing my blob content. First thing I would do is I would prepare a URL to access the blob storage. In this case, it would be the intellipix.blob.core.windows.net, whatever your Azure account name. I would use a default Azure credential. Now, by the way, this is using code from the new Azure SDKs. Azure is in the process of creating a somewhat more unified approach to its SDKs and putting them all under some common umbrella, some common patterns, some common behaviors. So there's, you can recognize the new ones because rather than starting with Windows dot or Microsoft dot, they just start with Azure dot. So in this case, the Azure Storage Blob NuGet package and related library can work with the Azure.identity provided default Azure credential. The default Azure credential is aware of managed identities. In fact, it's aware of several different systems for providing identity, and it goes through a hierarchy. It will try and first obtain a managed identity, then it will try and obtain I don't remember the exact sequence, but among others, it will see if it's running under Visual Studio and try and access Visual Studio or work with environment variables. It'll work with the running CLI. It just tries a bunch of different strategies to obtain a credential. One of them being, relevant to our talk, a managed identity. So if there's an ambient managed identity that it can work with, it will pass those credentials along as it's creating the instance of the client. And then we can use the client in our code to access information from within, from our code from the blob storage resource. It's a lot of talking. Let's actually take a look at seeing how we have to change our application to take advantage of this. So the first thing we'll do is we'll go back over to the Azure portal. And here in our web application, I'll come on over to the identity section, and I'm going to enable a managed identity, a system assigned managed identity for this web application. And that should just take a couple of seconds, and it's enabled. You'll notice it's got an ID of 66DB, etc. If I come over to Azure Active Directory and I look at my enterprise applications, I can actually see intro to, it has actually created that instance, 66DB, etc., as a service principal inside of my Azure Active Directory, which I can see here through the Enterprise Applications tab in Active Directory. The next thing I'm going to do is I'm going to go into my storage account that I want to access. And over here in Access Control, I'm going to add a new role assignment. And I'm going to select the Storage Blob Data Contributor. And I'm going to add to it my Intro to Managed Identities application that I just created. Save that, and now that application is a Blob contributor in this particular Blob account. Back over here in my code, what I will do is I'm going to come into the startup area, and I'm going to comment out where I was creating my client for accessing my storage account. And instead, I'm going to update it with a slightly newer version. Now, before I do that, I am going to add a new NuGet package here. I'll go ahead and Azure.identity. And I'm going to use this slightly newer version because it works a little bit better with Visual Studio with debugging credentials, which we'll talk about later. But go ahead and bring that in. And okay. Yep. And now back for my connection string here. And it should need to resolve this. So I'm going to go out and I'm going to get this part storage managed identity string rather than just the one that I labeled part storage. And then I'm going to build up my blob URI based on the information in the connection string. I'm going to create a default Azure credential, and I'm going to go ahead and create my client with that instead of just using the raw connection string. I'm going to right-click and publish this to buy us some time while I explain something. So I've updated it with the new connection string. If I come back to the Azure portal and I look at my web application, ahead of time, in the interest of time, I've gone ahead and added this new configuration string. And we'll see down here in the connection strings area, if I bring up the advanced edit so we can compare, we had our parts storage original one, and it's got the account key in it. Notice our new parts storage connection string. It just lists with the account name and the fact that it's in the Azure public cloud, and I want to use HTTPS, but there's no secrets inside of this particular connection string. So if my code has finished publishing, oh, it is being grumpy. Hold on a minute here. Let's try and publish one more time. I believe the speed to publish is directly proportional to the number of people watching the screen. Okay, there we go. And now as the page loads back up, as the website restarts, it should be getting access to that the blob storage now by using the new connection string rather than using the old one. And we'll just wait a minute here for it. Okay, and again, do we still have the data? If I happen to go to the health endpoint, we'll see my blob storage connection string is now using the shorter string. So it's the functionality is effectively the same. It's just using a mechanism for accessing the data that doesn't include storing sensitive information inside of my configuration or inside of my portal configuration area. Okay, now I have time for a quick question. I see there might be one over here. Let me see if I can bring it up in the tool here. Okay, so the question is, do you mean we can replace remote desktop ID and password to access VMs? No, this doesn't work for accessing the VM at that plain level. This is more for the VM needs to access a resource within Azure. For instance, it needs to connect to a database or it needs to access storage. This would replace having to hard code those credentials somewhere into that VM before we publish that VM. Or again, in this case, we saw a web application. I didn't have to put those credentials inside of the configuration area. Okay, so that was working with storage. Another very common one is, well, and I just mentioned, what about working with a database? How do I keep from having to embed sensitive things like username, password, or create an app-specific username, password inside of a database connection string? And we can go ahead and work with that as well. Now, it's a little different because Azure SQL Database Role-Based Access Control happens through the database itself, not through the portal, not through the management plane of the database service, but it happens through the execution plane of the database itself. And it's a multi-step process. First, the recommended approach is, rather than assigning an individual user, create an Azure Active Directory group and add it as a user inside of the, add to it the users and applications that you will need to access the database. Then set an Azure Active Directory administrator for the database in Azure and access the database through a tool, a SQL tool of some kind with that credential. And in the database itself, configure the Azure Active Directory group as a database user with the access that it needs. In this case, MySQL DB access group is being given reader, writer, and data definition admin permissions. It's pretty widely scoped in this case, but you get the idea in that I can then go ahead and treat that Azure Active Directory group entity as a user within the database and use the database controls to limit what can be done. When I do this, again, the code that I would update, I can create a credential-less connection string in the application. Then I once again use the default Azure credential from that Azure Identity NuGet package, and I can specify a context for the token it's going to request. In this case, it's database.windows.net / is the token that you would use, or sorry, the scope that you would use to access the resource. The only problem is the V2 endpoints don't react very well. V2 Azure Active Directory endpoints don't react too well with scopes that end in trailing backslashes. So decorating it with /.default allows it to work properly, allows it to get past the problem it has with that trailing backslash. Just a little note in case you run into the problem, because it can be a little difficult to detect what's going on there. Anyway, once you've got the scope that you want to retrieve your token for and the credential that you want to use that in, you can use that credential to request a token. And then in my database connection, I can set its access token to be the token that I retrieved from that default Azure credential. Again, let's go back to our code and actually see that in progress or in use. So I will come back to the portal. And I will come on to, again, Azure Active Directory and groups. And I've got a group in here called Intro to Managed Identities group. I'm going to update the members of that group, and I'm going to add a couple members. I'm going to add my application, so it would be intro, and that's that same old identity that I created for the web application. It's available to be added to groups. And I'm also going to add myself because I'm going to need him in there later. So I'm now a member of that group. The next thing I need to do is I need to go back to my database. And in my SQL Server, I need to set my Active Directory admin. I already have, I've set myself as that. And I can come on over here to the Azure SQL Data Explorer, and I can connect to my database using those credentials. In the interest of time, I've already done it. What I'm going to do is I'm going to run a new query on this database. Get this query in here and run. And again, I've taken that group, added it as a user. I've given him the permissions that I showed earlier. And you'll see if I refresh my users, of course, I've been disconnected from my database. Okay, half a second here. Security, users, and there it is. The group is there as a user on the database. The next thing I need to do is I need to come back into my code and update my code to use the managed identity to get my database connection string. So the first thing I will do is I'm not going to get the full connection string anymore. I'm going to get the abbreviated connection string. Oops, I've modified the wrong bit of code here. Let's try this again. Okay. So I'm retrieving this managed identity version of the connection string. And then over here in my database context, in the constructor, as a handy place to do this, I'm going to go ahead and set it up to retrieve that token for me. So if I'm using a SQL-based database rather than a this application uses SQLite when I'm debugging, but when I'm in the full-blown SQL version of it, go ahead and get that credential, request indicate the scope, indicate the context, get the token, and my connection access token is now set to that. Once again, right-click and publish. And while this thing publishes, again, I'm going to come back to the portal. I'm going to look at my web application. I'm going to look at my configuration, and we can see the difference between the two connection strings that are being used. The original database connection string had username and password in there. This one is the same connection string, just minus the username and password. And if I come back to my running code, which should be loading up right now, okay, it's up and running. And I can, the database backs the login functionality. So if I log in, it's able to access the database. Log out. And if I go to the health page, I'll do it over here, we'll see my database connection no longer has user credentials in it. So again, the application was able to present itself as the identity, and my connection string is fairly innocuous. My junior developer gets a hold of it. If it gets checked into source control, it's not going to be the end of the world here. Okay. Now, beyond storage as a basic service and database as a very common service, well, what about other services? And we saw the chart earlier on. There are a lot of services that are supporting this. There are some that aren't quite there yet. So what do you do if your particular service doesn't support all of this? Well, Azure Key Vault can step in and kind of be the great equalizer here. Azure Key Vault is a mechanism for storing secrets, certificates, and cryptographic key information securely inside of Azure. what this allows you to do is for keys, it allows you to centralize your encryption keys. You can either import or generate new keys. The new keys that are generated can be generated in hardware security modules. The keys that are generated never leave the key vault boundary. When you actually request to encrypt or decrypt data with keys that are stored in Key Vault, you're actually requesting Key Vault. You give it the data to act on, and it returns the result to you. So your application never even has to pull those keys in. Azure Key Vault will also store secrets, so you can store passwords and access keys and connection strings in there. One advantage of doing this is it allows your operations team, ideally, a single place to go to update, refresh, and manage keys or secrets that it needs to rotate, replace, or otherwise work with. If it didn't do that before Key Vault, if we had a storage account key and that account key was compromised and we needed to replace it, well, now we had to run around through every possible application that might maybe possibly use that storage account key and verify that it didn't. With Key Vault as an intermediate, we can know, okay, this is the place where the secrets are. We can update the secrets here, and all the consuming applications downstream should receive the update. It turns out Key Vault can use Azure Active Directory role-based access control for management and access to the keys that it happens to store. It does this, or one of the ways it does is with access policies. So one of the things that we can do here is we can set up a predefined secret management access policy, or we can even thin the list down further. We can indicate which principles this will apply to, and then that will govern the access for external entities into the values we store in our Key Vault. To work with this in code, there's a lot of ink here, but it's fairly straightforward, very similar to what we've seen so far. We can use the Azure Key Vault SDK. Again, another Azure dot, one of the new SDK items. We identify where our Key Vault is. We create the default credential, and we create a secret client to access secrets within Key Vault. We can then request the secret by name and retrieve the value for that and go ahead and use that. So in the case of our code, let's go ahead and work with that. Come on back to the portal here. And we're going to go into our Key Vault. We've already stored the connection string for getting hold of our Azure table storage here inside of Key Vault. We'll go and we'll create a new access policy. And I'm going to add a new policy. And I'll start with the secret management template, but I'm going to severely restrict it. In this case, I only want to be able to get a key that I've indicated. I don't even want my application to be able to list keys. I'm going to indicate the principal that I want to have this access. In this case, it would be intro to managed identities. And I'll go ahead and add that policy and save it. So now Key Vault is granted access to anyone who presents themselves as intro to managed identities to be able to get secret values that they happen to be requesting. Back in our code, I'm going to come into NuGet and pull in the Azure Security Key Vault Secrets package. Let's use the released version of that. And okay, with that loaded, I can go on into startup here, and I can see where I'm pulling the table storage access connection string and client. And let's go ahead and use a revised version of that. And update the usings. And this is, again, that code that we just saw on the slide. Locate our Key Vault, create an instance of credential, create a client to access secrets, request the secret and get the response from it, and then from there retrieve ultimately the connection string value out of that secret. and then pass that on into a table client and go ahead and use it. Now with this one, it's a little bit different than the previous ones. We'll go ahead and publish it, in that the health check is actually still returning the full value because we're going into Key Vault to get the value that has the key embedded into it. And let's see, we'll give it another second. Okay, publishing is being stubborn. Let's go ahead and cancel that and try it again. Let's see if we can get it moving along. There we go. Okay, and while that's publishing, let me see if there's any additional questions. I don't see any additional questions.
There are quite a few, John.
Oh.
Look at the bottom.
Yeah, and it's just this, the tool here is, oh, there we go. Okay.
Got it?
Yeah. Okay. Okay, this must be, I don't see, now I see John's screen. Ah, yes, okay. So we got the slides not advancing. Is this session recorded? Yes. Keep an eye on Wintellect's Twitter handle and for information about those. Remote desktop noted. Can we create the managed identity automatically and do the RBAC to the resources? Yes, you can use ARM templates to configure to automate the configuration of the creation of the managed identity and the association for the role-based access control. By ARM template or other options. Okay, yeah, continuing the question there. And let's see. How about Cosmos DB? I don't believe Cosmos DB is there yet. Off the top of my head, I don't think it's there yet, but this Key Vault approach as an intermediary works it. Okay, yeah, there's a question about, yeah, I don't quite follow how this breaks the chicken and egg cycle. The idea is we no longer have to embed our credentials into our application in order to realize the identity that we're going to then use. The applications that support this running in Azure can be aware that there's an ambient managed identity that they can use without needing to create the credentials to realize the thing that we're trying to do to avoid having to embed credentials. Are Azure managed identities only for Azure resources? If I have an on-premise server, can I use managed identities, or do I have? It's a good question. It can basically managed identities be used for on-premises resources? I believe you're kind of stuck because using them for Azure resources. I mean, they are just service principals. But I believe they're mostly just for in Azure resources. Certainly they'd be limited to, you can only use one as identifying myself when you're inside of Azure. But if you then wanted to reach out to something outside of Azure with that identity, it would also have to be under the governance of that same Azure Active Directory. You might be able to really work around it, but I think it'd be kind of a far journey to go. And Key Vault versus Azure App Configuration. Yeah, the new Azure App Configuration Service versus Key Vault as a place to store configuration information. Boy, that's a tough one. I've kind of wondered that myself. It does kind of feel like there's significant overlap, and it becomes a matter of splitting hairs between the definition of a secret and a definition of a setting. Is really where they go. There are some features that are different in the two of them, but it really, you know, where should I store things? Should I store this in Key Vault or the new app settings service? I believe the functionality is going to be fairly similar in that regard, but it becomes a matter of, do you consider your configuration strings to be settings or secrets? And then that would dictate where you're going to go with this. Is the demo app available on GitHub? Not yet, but we can look into making it there. What's preventing a rogue app from identifying itself as your managed identity and getting itself access to your Azure resource? Well, the fact of the matter is and we'll see this in a second when I go into VMs, the app running inside of Azure is reaching into Azure. I can't have an app outside of Azure saying I'm that app. And for that matter, the app, when it kind of asks Azure, who am I? There's some code under the covers here that's asking Azure, who am I? And Azure is going to reply, you are BDD, etc. that we had before. Azure will not give that app that answer to a different app, or Azure AD technically won't give that answer to a different app. So that kind of locks it down to this is definitively this app running this way. Okay, let's take a look at this. This is deployed. Sure enough, it's still showing the parts, so we still have access to the table. If I go back to the health endpoint, it's going to show the account key in there because, well, we had the account key in the key vault resource. But we do have that level of indirection there, so it's no longer directly tied to our running code. Let me get a move on here because I know we're running low on time. Virtual machines, and hopefully when I talk about virtual machines, it'll also help understand where things are in terms of how these values are specific to a given app. So virtual machines running in Azure have access to what's called an Azure Instance Metadata Service. When a machine is running, when a VM is running in Azure, it can make a request to a specific IP address. It's this 196.254, 196.254. It makes a request to that, to a few different endpoints under that particular IP address, and Azure will respond to it. You can ask things like, well, it's a bit of an existential question, who am I? The VM asks that question, and Azure can reply with, you are this virtual machine running with these network settings in this instance size, in this SKU, and other various informations. Azure will tell the VM information about itself. Now, if I try and take that same VM image and run it outside of Azure, whether it be in AWS or running on Hyper-V on my local machine, that particular IP address isn't available. We're not serving it up. We can't answer that question. So it's really only something that works when you're running inside of Azure. It's basically saying, hey, you running me, tell me about myself. It happens to expose an identity endpoint that you can use to request tokens. So if a managed identity is enabled on the VM, you can say, please give me a token for accessing a given resource. The token will be generated, and then your code can use that token as a bearer token to make a request, however you may be inclined to make that request. Let's actually take a look at this. I happen to have a virtual machine here, back in the portal. It's just a Linux VM. And if I remote desktop, before I remote desktop, I'm going to enable a managed identity on it. So now it's, Azure is saying, I'm going to give you an identity. It's this 9A3 identity. If I come on over and connect to it and secure shell, and in fact, I'm going to bring up a terminal window here, and I'm going to SSH into that VM. And great, I'm SSH'd into the VM. Now I'm going to make that curl request to that metadata endpoint, instance metadata endpoint, and you'll see I'm going to ask for an identity, basically an access token to the database.windows.net resource. And boom, it's returned me this big old access token. And you can put this in your code and retrieve your access token that way, and then whatever code you're running can then go ahead and use that. If I examine this token, I can use a site like jot.ms to peek at a jot token. I can see that the token is intended for an audience of database.windows.net. It was issued for client EDBB, etc. If I come back to identity here, you'll see that the identity I was given, 9A3. Oopsie. Actually, I know where I can go get this. And if I come to Azure Active Directory, and enterprise applications, all applications, intro to, which one would be the lowercase? And I may have stepped on my tongue on this one. Well, I'm just going to walk past this, but I've done something where my identity, my subject ID isn't proper in here. But nonetheless, you can see I've got the access token that I needed, and I'm able to pass that access token along to the service to get access to the database. Okay. So the last bit I have here in our last few minutes is, okay, well, what about running this on my local machine? What about developing and debugging? And this is where that default credentials comes in, and that it's good and can get some information about the environment beyond just, am I running in a managed identity? It can ask things like the Azure CLI. If there's a CLI instance running, who are you? So you can log into the Azure CLI and it can reach out there. It can leverage environment variables if you happen to have them set. Or if you're running inside of Visual Studio, it can use the local Visual Studio user account and its connection to Azure to make a determination about what you're connected to, about what credentials to use. So in this case, remember earlier on, I had gone ahead and said when I was configuring things, let's make sure we add John in there too. A couple places I didn't because I'm the owner of the subscription, but what you want to do in your environment is make yourself a developers group, add your developers to that, and set the RBAC permissions for your developers on your services. So then when they're running here inside of Azure and they run a local instance and hit F5 and wait. Here we go. And this is now running, well, as it slowly starts up here, we should see it light up in localhost. At some point when it's ready. Okay, let's make sure the Studio seems okay with things. Oh, there it is. Okay, this is running on localhost. If I go to a health endpoint though, we'll see it is actually connecting to the remote locations with those various credentials. And it's doing it because in Visual Studio, I've configured Visual Studio to have a connection to Azure using my personal credentials, which are included as having the right role-based access control to those resources. So this continues to work in a development environment as well. Okay. So some things to be aware of when you're using managed identities. I talked earlier about the differences between system assigned and user assigned managed identities, and they have different lifetimes. A system assigned, when you delete the resource, that managed identity gets deleted, as well as any role-based associations with that identity get deleted along with its deletion. User assigned will outlive the service that they're attached to, and then if you're going to be recreating instances and things like that, that may be an option for you to consider. If you're going to change Active Directory tenants, if you're going to take your Azure subscription and put it under a different Active Directory tenant, be aware that when you do that, and this sometimes happens when companies get acquired or other things, when you do that, all of your role-based access control breaks because the Active Directory that's been attached to establish all these role-based relationships is going away. It's no longer attached to your subscription. So you need to account for downtime or other issues if you move a subscription from one Active Directory tenant to another in that environment. And then somebody had asked earlier about the configuration. You can enable all this with ARM and I believe with the CLI and PowerShell as well. There's one more question that came up here. Do you need to be logged into Windows with your AD account, or is it enough to be logged into Visual Studio? I am not logged into Windows with my AD account, so Visual Studio was enough for me in this particular case. And again, there are supplemental cases. There are problems, if you have too many subscriptions, too many identities, or things can get a little confused, but that's where you can supplement things with the environment variables or with the CLI instance and have it pick up from there to help resolve in the instance of questions, or if it doesn't know exactly how to resolve your credentials. Okay, with that, that's all that I had for today. I'll be happy to take any additional questions here for the couple of minutes that we have left. Also, please do not forget the special offer if you're interested in some of the training options that Wintellect is offering. But yeah, if any questions, otherwise, thank you all very much for having been here today. How about for service users? I'm sorry, I'm not following the question there about how about for service users. Okay, applications that are not logged into AD. Okay, well, remember, an application running on your desktop, for the most part, won't be able to have an ID in Azure. If you think about it, it would need to, similar to what the virtual machine did, it would need to reach out to an address in Azure, to a service in Azure and say, who am I? If it's running on your machine, it can't do that. So what it would need to do is you would need to tell it, I'm a person, I'm John Garland, I'm a developer. When it's in Azure, it can reach out to Azure and say, who am I? And Azure will respond. Let's see, very useful information, thank you. Can you share today's recordings in PowerPoint? Yeah, keep an eye on the Wintellect Twitter account, and we will go ahead and publish additional information about this webinar through there. Can we email when resources are available? Martha or Rachel or do we send out emails that way?
I can send you a message.
Yeah.
Okay, yeah, I believe we can have emails sent out to the attendees. And thank you, Ed. Okay, well, thank you all very much. And I'm sure that there are some great additional Wintellect webinars coming up. Please stay tuned for them, and we hope to see you there.